This brings us to another LRO oddity. While the more recently released 100km images of Apollo 12 and 14 show bootprints, the earlier images of Apollo 11, 15 and 16 show none, and 17 shows only a faint trace. That's despite them having a resolution of between 1 and 1.5 meters per pixel. It's almost as if they forgot them early on. Then when they got round to Apollo 14, someone said, "We really ought to put some tracks in there to make it, authentic and all that." So they put some tracks in at a reasonable 15% darkness. Then while working on Apollo 12, the boss said, "Damn, I can barely see it. Make them a bit darker, will ya?" And the photoshopping guy said, "No problem," and upped the darkness to 30%. As a result, they were left with photos ranging from no bootprints to reasonable prints to way too dark prints. In situations where you can't retract your work, planning ahead becomes a good idea.
It isn't primarily the bootprints themselves which cause the discoloration in the surface. You have provided a film clip in your own video which gives us a fine example of this. Here you have shown how light the tracked areas are compared to the LRO photo. First of all, this is not the same section of tracks that you show in your LRO image. It's not even the same Apollo mission. This is the area in question, and it seems to be about the same contrast to me, although not the same brightness. In this same picture we see a darkened area which is due not to the few bootprint impressions that we see, but because of the dust which has been kicked around. Thank you for providing us with that image.
Well, I never said it was the same section of trail. The image was only a sample for comparison. Still, the point he makes about the surrounding regolith looks like a possibility. I'll examine it here. First of all, how dark is the lucent regolith compared to the surrounding surface? By comparing the trail at various points, the answer seems to be between 9 and 12%, or on average around 11% darker. Obviously, a trail made entirely of this will be insufficient because we need to show the darkness to be around 30% like this. So how about mixing this dark stuff with regular bootprints? Under normal circumstances, that might work, but unfortunately, my created bootprint trail is already 100% occupied by bootprints. There's no space in between for any loose material, and the regolith beneath each boot is compressed. To get loose regolith in, I'd need to remove some of the prints, but that would make the overall trail lighter. Again, we are back to the original problem. Using a normal length stride, a trail like this would require a huge number of prints to match up the LRO contrast. It would take one person walking over it 12 times, or 2 people 6 times, with no overlapping prints or missed areas to get the density shown here. That's possible around the LEM, where the astronauts would have had to unpack their equipment and would surely have trod between the gaps of their previous tracks, but highly unlikely walking between stations, where only 2 astronauts walked once in each direction. Another possible reason why the kicked up regolith looks darker is because it actually is. In other words, there may be a thin layer of light regolith covering the surface and the astronauts' boots dug through it and kicked up darker material underneath. If so, it would be possible to achieve the 30% darkness requirement by having only 2/3 the number of prints made of and mixed in with darkened material. To address this possibility, we'll again look at the newly released high-resolution image of the alleged Apollo 17 site. Notice that there are walking trails covering both light and dark areas of the lunar surface. If the darkness of the tracks was due to the kicked up subsoil, we'd expect the track in dark areas to be rather faint. Instead, the track has 30% darkness in both dark and light areas. For example, the light area here has a brightness of 105, while the tracked area is 76. While over here, in the darker area, the surrounds are 68 and the track is 48. So the track is 30% darker in both cases. And though harder to see due to it being darker, the same is true of the tracks in the so-called raw image. In this dark area, the track is 14 and the surrounds are 21, while in this lighter area, the surrounds are 31 and the track is 23, so again, about 30% darker. Therefore, unless the brightness of the subsoil varies in direct proportion to that of topsoil, this new Apollo 17 image would appear to rule out the possibility that this degree of track brightness is due to exposed subsoil.
And finally, the very images you have used in your video are not necessarily true representations of brightness or contrast. My Apollo 14 LRO image is not as dark as yours, and they are from the same digital photograph from NASA.
I can assure you that the LRO images I use in my documentaries are indeed the original releases. I stayed up all night on July 17th just to see the release of these images and attend the press teleconference. I downloaded these images as soon as they were released. To explore why Astrobrant's image seems lighter, I went back to the same web page where I originally downloaded these images. It seems the LRO photos have since been brightened since the press release, for reasons I don't know. It's also interesting to note that they changed the annotations too. The tracks were originally labelled as astronaut footprints. It now reads astronaut footpath. It's obvious that Astrobrant is using the latter. Just to be sure which of the two images is showing the correct brightness, I went to the LRO website where one can download the so-called raw TIFF file. Would you believe it? The raw image is slightly darker than my copy. It makes Astrobrant's file, literally, pale in comparison. So Astrobrant, I think it can be confidently stated that my version is indeed a more true representation of brightness and contrast than yours. Sorry, mate.